Hello. All right. Now we're on. All right, guys, thanks for coming back. Hope you enjoyed lunch. Thanks again to the sponsors. We are just 5 minutes past on the schedule. Our AV guy went missing. I don't think he knew we were starting a little earlier before noon. But we're going to go, the next set of presentations are all for remote folks. They're all online. So this is the lightning talks portion of the agenda for Florida mapping updates and plans. And we're going to start this session off with Katrina Wiley from NOAA to discuss NOAA's OCS to discuss Blue Topo. Katrina, hopefully you can unmute your mic.
Yes, I can hear you. Can you all hear me?
Yes, we can hear you.
Excellent. All right, I'll get started. Thank you. So I'm Katrina Wiley with NOAA Coast Survey. Coast Survey is mandated to provide navigation products to support maritime commerce. So the National Bathymetric Source Program builds and maintains a seamless and high-resolution model of bathymetry to support navigation. We use a merge process to determine the best available bathymetry for every patch of seafloor, and that process primarily evaluates hydrographic quality metrics of uncertainty, feature detection, and seafloor coverage. But we also allow for decay in time and space, and we pay close attention to vertical and horizontal datum transformations. The design and implementation of the National Bathymetric Source Program involves intentional use of open source software and code to ensure flexibility and to follow the FAIR principles that were highlighted in one of the talks yesterday. Next slide, please. Or do I control it? Perfect, thank you. The national bathymetry is derived into several distinct pipelines that differ in the contributing sources, the vertical datums, and the formats that are targeted for the different user requirements. So besides our navigation pipeline, we support our own planning and prioritization efforts through an internal pipeline. And while navigation services are Coast Survey's primary mandate, the metadata, transparent metadata, and the merge algorithm, supersession algorithm that we use to determine best available bathymetry can also be used to support marine modeling and spatial planning, which we support with a public pipeline. So the public products are split based on vertical datum, where the modeling products are provided on chart datum, for example, mean lower low water or low water reference plane. And the Blue Topo products are provided on the current vertical datum for the US. So for example, NAVD 88, North American Vertical Datum of 1988. Next slide, please. So I'll focus the rest of this lightning talk on how to access the public Blue Topo products and go through an example of the provided metadata that you get with these products. Additional information on Blue Topo, including the specifications, can be found on NOAA Coast Survey's Blue Topo webpage. And while we have the initial Florida region built and we've been maintaining it with new sources, we are very excited to add in all those great TopoBathy and Bathy sources that you're collecting right now and in the future as they're made available to us. Okay, next slide. So how do you access Blue Topo products? Next slide. We have an AWS bucket set up, and this is where you can get the public products. So both Blue Topo and modeling are here. Within the Blue Topo folder, there's going to be a tile specification, which I'll talk about. And then also every tile has a geotiff and a raster attribute table. So the geotiffs are 3 layers. They have elevation, uncertainty, and contributor. And all that information, the metadata about the contributors, is held in that raster attribute table. Okay, so you can get your data directly through the bucket. Next slide. You can take advantage of the tessellation geo package that's in the bucket, where if you were to open up this geo package in QGIS or ARC, whatever, and you identify a tile in the identification window, there's a link that goes directly to the AWS bucket to pull down that specific raster attribute table and geotiff of that tile. So that's one way you can interact with the tessellation geo package. Next, please. If you are Python inclined, we also post some code up on GitHub to interact with the AWS bucket, where if you want to bring down many tiles and if you want to make a VRT, so like a surface of those tiles, there's code provided that will allow you to do that. And then anytime we update the products in AWS, you can run that code and it'll pull down any updated tiles for you. So that is available through GitHub. Next slide, please. And one of the more public-friendly ways to access Blue Topo data is through NowCoast. So Coast Survey has a website through NowCoast, and one of the layers on there is Blue Topo. So you can visualize elevation, uncertainty, and contributor. The contributor layer is being updated with a new plugin, so you can actually get at all the information in the raster attribute table. But one of the great things here is you can zoom around the coast and check out the bathymetry. There is a link to a web map tile service. So if you want to use this in your favorite GIS, you can also connect to it that way. Again, this gets updated as soon as we post new data in the AWS bucket. This viewer gets updated. Okay, next slide, please. I will go through just a quick example of one of these products and what it looks like. So if you get the opportunity to check it out, this is what you might see. Next slide, please. Okay, so this is just a whole bunch of tiles opened up together, not in a VRT, just separate tiles. And you're looking at the elevation layer. I don't have an image for uncertainty, but the next layer is uncertainty. So you'll have an uncertainty value at every node. If you could click, please. Thank you. And then you can also look at source survey ID. So again, we find the best available bathymetry for every patch of seafloor. And so that best available and identified, and you can click and say it came from this survey specifically and get the information from that survey. Next slide, please. Another attribute in the raster attribute table that you can classify color by is a source institution. So this is, who collected the data, the responsible party. And so in this example, you've got NOAA Office of Coast Survey in blue. You've got NOAA National Geodetic Survey, so the topography data from our remote sensing division in pink. We've got Army Corps of Engineers New England District data in red, Army Corps of Engineers GeoPolitics data in yellow, and we have some USGS data in green. The list of external sources is ever expanding as more and more people are sharing their data and want it to be publicly accessible. Next slide, please. So we talked about how when we do our super session, features, coverage, and uncertainty are really important to indicate quality. And so one of the metadata attributes that gets carried forward is feature detection, true or false. So you can see which patch of seafloor detected features. There's also 2 additional attributes for features: least depth, true, false, and feature size. So what size feature was detected that you can get at in the product. Next slide, please. So same with coverage. It's a binary true, false. So was there an actual measured depth at this location, or was it some kind of interpolated estimate from either side scan sonar support, or if it's just a gap in data that we interpolated? There's no bathymetry coverage for that node. So that's features, that's coverage, and then finally vertical uncertainty. Next slide, please. So again, uncertainty is on the second layer of that GeoTIFF, but we also have it in the metadata as different classifications of vertical uncertainty achieved. So the classifications being 0.5 meter, 1% of elevation, 1 meter, 2% of elevation, 2 meter, 5%. So you can see, and NA is just where it was complete gaps. We just interpolated across. But you can see here, like the distribution of where your vertical uncertainty was tighter or not. And I think this speaks well. I think Chris Taylor in his talk yesterday had a line about bad data, bad models, bad decisions. Obviously, uncertainty is really important for a lot of our downstream users besides navigation. So it's important that we provide that to make good decisions where there is data to support those decisions. So that, next slide, please. That is all I have. If you have any questions about Blue Topo using the product or accessing the products, you can always reach us at ocs.nvs@noaa.gov. And again, we can't wait to get all this data integrated into the national bathymetry and into our different product pipelines. Thank you so much.
Great, thank you, Katrina. We started a little late, so I'm not sure where we are. I'll open up if there's any quick questions, anything online, maybe a question or two. We're going to do them at the end. No questions until the end. All right, write them down. So we will move on to Christina Fandel from NOAA, also from OCS. Florida, her topic here is the Florida Coastal Mapping Program.
Hello, hi, my name is Christy Fandel. I work in the operations branch within the Hydrographic Surveys Division. So today I'm going to kind of talk about our hydrographic surveying program, what resources we have available, and how we determine where we deploy our assets. Next slide. All right, so within Coast Survey, we have mapping and charting responsibility for throughout the United States exclusive economic zone. So if you to kind of communicate the magnitude of that problem, that's around 3.6 million square nautical miles. We've surveyed around 1.85, or our latest estimates, million square nautical miles. And because we do around 3,000 square nautical miles per year, if you do that quick math, we're looking at around 580 plus years to survey the US EEZ with our existing resources, which kind of highlights the importance of these partnership external data resources so that we can help meet this mapped status at an earlier time frame, because I certainly will not be around in 500 years. Next slide. So one of the kind of the paradigms we like to say is let's get the right resource to the right place at the right time. So understanding what resources we have available in-house, we have, and within our NOAA hydrographic surveying fleet, we have 4 primary hydrographic survey vessels. We have the Rainier and the Fairweather on the West Coast, and then of more interest to this group on the East Coast, we have the Thomas Jefferson and the Ferdinand Hassler. We also have a large $250 million hydrographic surveying services IDIQ. It's an architect and engineering contract, which means that the selection is based on those most qualified vendors. And so at the bottom, you'll see the logos of the 7 vendors currently on our contract. And we do around 50% in-house work and 50% contract work on any given year. From a contract perspective, that breaks down to around $30 million of hydrographic survey task orders annually. Next slide. All right, so we know what resources we have. Now it's really important to make sure we deploy them to the right place. We understand that the scope of the problem is larger than what our resources can support alone. So this is just a map kind of showing the latest BAFI gap analysis done by Coast Survey, showing that 52% of our area is mapped, leaving that 48% or 1.8 million square nautical miles unmapped. So what this means is that we need to make sure that we're encompassing a lot of parameters to make sure that those limited resources are deployed to the appropriate location. So if you click the button, it should have an animation. Great. All right. So what are those parameters? There's a lot of them. We look at the number of groundings. We look at how many known hazards are there in the area, how many unknown hazards, what's the age and quality of the bathymetry data when it was last acquired in the location, how close is the area to sanctuaries, reefs, and other environmental areas. So the way we encompass all of these parameters is by modeling it through the hydrographic health model. So if you can go to the next slide. The hydrographic health model is made up of 3 primary parameters. We have the desired survey score, and that desired survey score aims to understand what's the quality of the bathymetry that we need to support current surface navigation. So it looks at how close vessels are transiting to the seafloor. So if you're transiting closer to the seafloor, then we want a higher quality level of bathymetry. But if you have a lot of distance between the hull and the seafloor, we can kind of relax that quality metric. And then that is looked at and differenced with the present survey score. So what is the quality of the bathymetry, understanding that the seafloor changes over time? So for those surveys acquired at the same time, same metrics, if one is in a highly changeable area, it will decay at a faster rate than a survey that's not in a very changeable area. So if you take the desired survey score and difference it from our present, we get what we call the hydrographic gap. And that's really going to highlight where the quality of the bathymetry that we know that we have today is insufficient to meet the needs of current surface navigation. That whole parameter is then weighted by hydrographic risk, and that's going to encapsulate a lot of the variables that we talked about on the previous page. Things like how many groundings are in the area, are there a lot of reported hazards, how close is the area to a major port, how close is it to a sanctuary or a reef. And by merging those two together, we get our hydrographic health model. And then you can see in the graphic, those warmer colors are going to show areas where we have a gap, where we need to deploy hydrographic survey work to get updated bathymetry. But the blue area highlights where, for surface navigation purposes, we're in a good spot. We have the quality bathymetry that we need. So we've got our resources. We now know where the right place is. Now it comes back to the right time. So if you can go to the next slide, please. All right, so Floridians will be very familiar with a lot of the environmental parameters that have an impact on your ability to conduct efficient survey operations. So for example, we have to be cognizant of ongoing fishing and lobster initiatives. We have to be cognizant of weather. We understand that there's seasonality to the hurricane season, and then general just wave analysis. So we incorporate all of these parameters to understand when should we deploy our very limited resources to survey those high priority areas. So next slide. All right, so here's kind of a case study, an example from along the Florida Keys from one of our hydrographic survey contractors, Geodynamics. They conducted this survey in 2021. And you can see from the graphic, they were able to assign the right resources to the place, right? They have a larger vessel that approached the offshore areas, able to deal with the wave conditions a little easier. And then they use the more nimble small boats to approach those nearshore environments. Geodynamics acquired full coverage multi-beam bathymetry in this area, and they were able to junction with existing LiDAR data. So that limited the nearshore close high effort area by the vessel-based platform. And a notable achievement by this project is that the survey contractor in our office did considerable outreach ahead of these operations, engaging with the local community, understanding what their survey needs were, and kind of publicizing what our operations were planned for the area. So despite many storm events in this time, this was also immediately post-COVID or the surge of COVID. So the people were starting to return for tourism. They were able to submit all of this data to specification on time. All right, so next slide. So kind of linking back into what Katrina had talked about, the Key West data and all of our hydrographic data are qualified by our hydrographic data experts within the Hydrographic Surveys Division to ensure compliance with the prescribed requirements. And then these data are shared to the public. We share them publicly via NCEI. We compile the bathymetry into the National Bathymetric Source, and then we incorporate the survey data into our navigation products and services. So that was my final slide. Unless there's any questions, I thank you for this time.
Great, thank you, Christina. We're gonna hold our questions. I see some questions coming in on the chat as well. We can review those at the end. Move forward. Stephen White from NOAA is going to present on the NGS Coastal Mapping Program. I skipped Sarah, I'm sorry. Sarah Grasty from USF, the COMET program. She's presenting on building a CSB program in Tampa Bay, community source bathymetry, and beyond.
Thanks, Renee. Thank you for having me, and I wish I could be there with you all in person, but there's plenty of my colleagues from COMET who you can also ask about what I'm about to present. And also, the last two talks set it up nicely because Office of Coast Survey is who funds us. So most of everything that we do is in support of their missions and their goals and operations and such. So if you could go to the next slide, please. So yeah, I'm going to talk to you today about Crowd the Bay, which there should have been a small caveat saying that it's a pilot program. So the end of our first round of funding for COMET comes end of next year. And so what we're trying to do with Crowd the Bay is kind of coincide the end of this pilot to happen at the same time and have it poised to become its own full-fledged, ready to go program. But first, so that we're all on the same page about what crowdsourced bathymetry is as defined by the International Hydrographic Organization, who has a international working group who has developed this definition, is the short of it is we're just capitalizing on collecting depth data from vessels who are out doing their own things that they typically do, and we're not using any kind of fancy scientific instrumentation to do that. Next slide, please. And then as far as what our role is at COMET and what we're trying to do kind of for the greater good and the broader context of things is part of our mission is to develop, test, and implement better, cheaper, and faster approaches to ocean and coastal mapping. And that can mean a lot of things. And what we are trying to demonstrate and just create further support for is that crowdsourced bathymetry is included in those better, cheaper, faster approaches. So if you go ahead and click, I think there's an animation. To summarize, we're just trying to generate more buy-in for showing why crowdsourced bathymetry is important and where the utility lies with it. Next slide. So as far as why doing it here is, a great place for something like this, and that's not to say that there aren't other extremely successful demonstrations of crowdsourced bathymetry throughout the world. But Tampa Bay specifically is a bit unique. If you could click. So if you didn't know, as of 2022, there were over 1 million boats registered in Florida. So in terms of having a potential crowd, Florida is certainly ground zero for that. Absolutely in the nation, if not the world, it's one of the densest areas for vessels. If you click one more time, Tampa Bay specifically itself has 2 of the top 5 counties for vessel registration as well. And so it's not only that we have a crowd, but Tampa Bay is also a very dynamic area and has a lot of shallow inlets and bays. And so in terms of needing more timely, updated depth information, again, just a really nice pilot area for this type of work. Next slide. So as far as the why are we doing this? Well, I think all of us here, this is a no-brainer. Good charts equal a good time. And so, how do we make sure everyone is going about safely enjoying the water? I think it's unrealistic to expect in terms of resources and everything that areas can be mapped as frequently, I think, as we all wish they would. Christy just showed a great, example of how things are prioritized and how Coast Survey goes about planning for where they're going to survey and everything. But, like I said on the last slide, Tampa Bay may have areas that change on quite rapid timescales, and it's not unique in that sense, but it just means that some depth measurements that are on charts may be outdated very quickly. There's also some very old data that's still old soundings that are still on charts that need to be updated. So this is where we think the crowd can really lend a hand and be part of safe navigation. And there's also other, applications for getting increased amounts of depth information in an area. Next slide. So we have broken our pilot program down into 3 major phases. So phase 1, and I will say these phases, even though they are chunked out this way, phase 1 and phase 2, for example, they never really stop happening. It's sort of just when do we sort of begin the next, tranche of tasks and goals. So for phase 1, that was a lot of foundations and relationship building. If you click forward, we are now in phase 2 and just kind of, I guess, coming out of it. And then now into phase 3, which is trying to build our crowd. And in phase 2, we did a lot of outreach, and I'll touch on that in a couple slides. Next slide, please. So the goal, and this figure is up here very affectionately. I'm not saying that people are dummies and we're trying to dumb science down for them. That's not it at all. People are really busy, and in order to feasibly build a crowd and sustain it, you have to make tools and resources and concepts. You just have to make it a little bit easier and accessible, lower those barriers to participation and everything. And so that's what we're really trying to do. So if you click again, I say crowdsourced bathymetry for dummies, but what I mean is we're trying to evaluate what's the cost benefit. If you just go ahead and click a couple more times, what's the participant effort that's required, and then what's the quality of data that we get. So if you click one more time, what I really mean, actually 2 more times, or 1 more time, I guess. sorry, I should have added less animations in this. So what we're talking about is just speaking to and creating resources for non-technical leaders in coastal areas and trying to give them the resources to eventually use what we're doing at Crowd the Bay as a blueprint and making it open source and hopefully having it spread throughout the state of Florida and wherever else it can be used. Next slide. So we, as I mentioned, the phase that we're just coming out of was really intensive outreach and stakeholder engagement. So if you click a couple more times, so what that looked like for us was doing some workshops. And so our first one was in September of last year. And I wanted to just shout out Dr. Mark Luther, who's at our college and is part of COMET and this program. And his community connections have been huge in getting people to come to us as part of these workshops and give their input and help us build the program. Next slide. I know I'm running up on time, so go ahead and click one more time, please. And so we held a second one just last month and had some new faces there. So the data from all of this work, I'm working on compiling now into a report that will be available within the next few months. Next slide. And if you click one more time or two more times, so the stakeholder engagement that we did was few presentations just to get everyone on the same page with everything, but the main focus were discussion sessions and the use of surveys and polls. So those data are what I'm talking about are being compiled. So the direct feedback from stakeholders and future participants to Crowd the Bay is what we're working on. Next slide. So this is an example of how we want to then serve the data back to our users. So this is crowdsourced bathymetry that currently exists in Tampa Bay. And we've put it in a web portal through an ArcGIS online service and have it available here. But there are plenty of other file types and ways of giving the data back that we have already heard from our stakeholders that we'll be working on as well. And I know that I'm up on time, so I'll have you just skip to my last slide and say thank you so much. And I'm again, sorry for running up on time, and I'm happy to take questions at the end, or please email me and visit our program website for some more information. Thank you.
Great, thank you, Sarah. We'll move on now to Stephen White, NOAA, presenting on the NGS Coastal Mapping Program.
Okay, good afternoon. Can you hear me?
We can hear you. Volume's a little low, but we might be able to raise it on our end.
Okay. And I'll try to speak up as well. Okay, so we'll go ahead and jump into this. Next slide, please. Just give you a little background of kind of where we sit. We are part of the National Geodetic Survey, but we are the Remote Sensing Division, or RSD. And we have three primary mapping programs, but the one we're going to really talk about today is the Coastal Mapping Program, or the CMP. Next slide, please. So the CMP, we have the congressional mandate to conduct remote sensing surveys to demarcate the nation's legal coastline with the goals of providing up-to-date national shoreline as well as acquiring nearshore elevation data. And there's tons of sources that we've used in the past for this. Next slide, please. But one of the real goals as of recent is really supporting our hydrographic surveys, where we would just like to come in beforehand, collect data, provide that data, whether it's the nearshore bathymetry, the shoreline, to our operations, so they can help or use that to plan the operations, utilize it for situational awareness, with the real goal of increasing efficiency and just the safety of the operations themselves. Next slide, please. And so the next slide really should show kind of the general areas that we've been acquiring. I'm still seeing the hydrographic survey slide. Next slide, please. Okay, there we go. Awesome. Okay, yeah, so it kind of shows where we've been operating as of the last few years. You'll kind of see everything on the left. That's really where we've been supporting a lot of the hydrographic surveys, whether it's the Pacific Islands and Guam, Marianas, Northwest White Islands, American Samoa, and then even areas of Alaska. These are just, really remote, unsurveyed areas. And you can see on the right side, that's where we've been spending a lot of time as well. And there's quite a few projects sprinkled in that have been supporting hydrographic surveys as well. But these are mostly larger campaign projects. Next slide, please. Okay, so I think what people here are interested in, the state of Florida, this just shows some of the recent data that we've been acquiring over the last few years. And just kind of note the Hurricane Michael data, that was actually pushed to Digital Coast a little over a year ago. And then in the next few slides, I'll just kind of talk about some of the other projects kind of quickly, the Big Bend extension, some of the pre-post Hurricane Ian, that Florida Back Bay block, that's what we're calling it, and then some of the East Coast projects. And there was one up in the northeast near Jacksonville. That was an aerial imagery project. They kind of came to us quickly and had tasked us with acquiring LiDAR for that to get at the needs of the project. Okay, so looking at some of the projects in Florida, this was coming out of the Indian River Lagoon project. So you'll see kind of on the right side, they were getting really good coverage. You know, there's some gaps kind of in the intercoastal. Kind of on the left, that's, you know, kind of typically what you'll see with Topobathy LiDAR. You're getting data in some places and you're getting voids in some other areas. If you can click, we should see a yellow circle come up in that left thing. So yeah, and if you click again, we'll just kind of zoom in, and that's actually a football field, or I tried to place a football field. So you can just see how quickly you can come in and, you know, acquire just large swaths of data with really highly accurate data as well. So next slide, please. The Big Bend extension, that project has been going for a little while. It has made it through our QA process. We actually have the revisions in-house right now. We just need to work through those, and hopefully we'll push this data out the door, hopefully pretty quickly. Next slide, please. There was also the pre-Hurricane Ian data that NOAA acquired, and we have actually had this process. It's currently sitting in our QA queue. It's probably about a month or so before we get around to this, but we're hoping to have this data out in late 2024 calendar year. So next slide, please. There was also the Hurricane Ian supplemental that's been talked about. These projects are currently in the acquisition phase. They're at different stages. I believe the northern one is a little more than 60%, 65% or so acquired. And the other one, it's kind of getting started in the acquisition, the southern point, more down towards the Everglades area. Next slide, please. Okay, this is, we were calling this the back block of the Keys, one of the areas we had left to do. So we spent a few mobilizations down here acquiring this data, and you'll see up kind of towards the north, those kind of red areas are like water surface returns, just areas we were having a really tough time getting data. And we've been there a few times. So at some point, you know, we stop acquisition. We kind of say, hey, this is what it is for the time being, and then we'll try to come back at a later time when environmental conditions have changed and this and that, to see if we can pick those areas up. Next slide, please. And I believe this next slide really kind of shows what we've been doing as of late, just really Topobathy gap filling. This actually really came about as we were accepting a new sensor. We kind of took it down to the Keys and just really just shaking the system down and seeing, you know, what we could do with it. And we really took a lot of our old data that was, you know, flown with different sensor technologies, a lot of different environmental conditions, and we just really looked at areas and said, hey, you know, these are areas we think, you know, with, you know, new technology or, you know, just better environmental conditions, we should really be able to acquire data in these regions. And so what you're seeing here in green, it might be hard to see, those are areas that we acquired. We feel like we've been getting pretty good data with that. And we had to go into maintenance, and then we hopped down to the Caribbean. We've been doing a lot more of this Topobathy gap filling in those regions. But at some point, we're hoping to come back and finish some of this up. Next slide, please. Yeah, and just to kind of mention some of the kind of more R&D things we've been working on lately. Really, the TPU, which is on the left side, that's actually the Fort Lauderdale kind of test site. And then we've really been working on normalized intensity. This is some data we collected back in October. We've been working with Oregon State to really, you know, come up with a standardized method for creating these normalized intensity rasters so that we can, support these standard deliverables or standardized deliverables. So next slide, please. And just a little bit of update on the TPU, where we are, you know, calculating total horizontal uncertainty as well as total vertical uncertainty. We've added some new sensor models in, the PILs, the RAM systems. With the next release, we're going to have both the Seasmil Nova, Seasmil Supernova included, and then future releases will include the Leica Carotera 5 as well as ISAT-2 modeling. I think the next slide is the end. Oh no, one more. And again, all of our data is distributed either through the Shoreline Data Explorer, whether it's Shoreline or whether it's the LiDAR and imager through Digital Coast. So all our data is made publicly available. And I believe that is our last slide. So next slide just has my contact information. So thank you.
Great, thank you, Stephen. All right, our last presentation before the break is Edward Albada from EOMAP. His presentation title is Benefits of Physics-Based Satellite-Derived Bathymetry to Complement Traditional Surveys.
Okay, thank you very much. And I know it's a lightning talk, so I have to talk very fast. So let's get into it. My name is Edward Albada. EOMAP is a technology firm. They produce satellite data from multispectral satellite imagery. Next slide. So our technique is a little different than the traditional and standard satellite-derived bathymetry. We actually have a proprietary algorithm that actually solves the radiative transfer function, which is the description of light path from the sun through the various mediums and then is reflected back to the satellite signal. But before we run this algorithm, we have to do the necessary corrections. We correct for the presence of land, sun glitter, atmospheric properties, water column properties, and then we run the algorithm, and then we can get useful information on either the seabed, which would be, for example, satellite-derived bathymetry, benthic habitat mapping, or reflectance. Or if we can't get a return off the seabed, we get information on the water column itself in terms of water quality. Next slide, please. So an example of this is in Dry Tortugas off of Key West. And I know Stephen had a little snapshot of Fort Jefferson, which is right next to this, but you can just click through this. I think I have 5 things to click through, but essentially this is a raw image, and we do the corrections, we produce a satellite-derived bathymetry, and at the end, what we did is we compared it against NASA's ISAT-2 sensor. So the ISAT-2 sensor is a really handy sensor when there is no in-situ data. And so it is a satellite sensor, so it needs to be all the standard corrections that we do for satellite-derived bathymetry. We do it for the ISAT-2 sensor, but then it gives us a tool for a comparison against the satellite-derived bathymetry. So you can see the direct one-on-one comparison here. Now, our technology, the radiative transfer function technology, it actually does not need existing data to provide satellite-derived bathymetry. The traditional empirical technique is essentially a comparison against pixel color against a known survey depth. But because we actually solving the radiative transfer function, we don't need the training data, we don't need the in situ or existing survey data to actually run our processes. And this is a major difference because this gives us the confidence to be able to go back in time where there may not be any recent survey data, and we can start generating satellite-derived bathymetry over time. This is a major advantage to our technology, and I'd like to give some examples of that. But next slide, please. So in addition to satellite-derived bathymetry, we get information on the seabed itself. For example, benthic habitat mapping. I don't have a Florida example, but this one is in the Palm Islands in the Middle East that we did for a dredging company. Next slide. Some of the uses of our SDB. I think the biggest selling point of our SDB software is the use of our technology into published nautical and admiralty charts. So I'm giving 2 examples here from the UKHO in Antigua and from the New Zealand Hydrographic Office in Tonga, where we're actually featured in the published admiralty charts, where you know, their survey vessels couldn't access because either it would be too rough or too shallow or a lot of reef areas and so on. So we complement their traditional surveys by, you know, covering the inaccessible places, put it that way. Next slide, please. Because we have a technology that we don't rely on any survey data, means we can go back in time. So we give an example here of Hurricane Idalia in 2023, looking at the changes from Hurricane Idalia at Coquina Beach, just south of Tampa. So, you know, we have 2 snapshots in time, pre and post hurricane. And then we obviously can calculate the differences in the seabed and track seabed changes due to the hurricane. So this is what we did in sort of the difference map here. And it really gives a good understanding of what the changes are taking place, not only on the shoreline anymore, but also within the seabed itself. Next slide. And using those 2 difference maps, we can start to compute the coastal change quantification. So this is an example we did in Fugro in the east coast of Australia, doing volume calculations of how their beach nourishments worked. Next slide, please. We also use it to understand the effects of structures on the coastline. So in this case, it was a breakwater that was placed on a very dynamic sand feature. And we were able to show not only the traditional accretion and erosion dynamics that take place on the shoreline, but also what's happening in the nearshore area, where we also saw accretion and erosion on the upstream and downstream parts. Next slide, please. So we also work with our industry partners. In this case, it was Woolput and IX Blue, to optimize their survey campaigns. This was a airborne LiDAR campaign in Beveridge Reef in the South Pacific. And we're able to demonstrate that the initial survey plan could be reduced by over 50% based on our satellite-derived bathymetry. Next slide, please. When we combine the benthic habitat mapping with the SDB, we can get really useful information, really good analysis. So we can look at changes in the benthic spatial domain and tie that in with the changes in the seabed elevations. And in this case, we were looking to see if there were any reduction in the height of the coral reef areas for an application in Tobago. So really helpful, useful information that engineers and scientists can use to understand what's happening, not only on the coastal areas, but also in the very, very complex, coral reef areas. Next slide, please. Sand sourcing is a big issue in Florida as well as around the world. Again, we have combined SDB and benthic habitat mapping. We can try to identify areas and pockets of sand that can be used for potentially using for nourishment areas. Of course, there are a lot of steps that go in after this, fiber coring and probably some more detailed surveying, but at least we can get a first pass in identification where these borrow areas may be. Next slide. I think I'm coming to the end here. So a couple of other applications in Florida. We did this for the Florida Fish and Wildlife, looking at identification of aquatic vegetation, not only native species, but more importantly, identifying where the invasive species are. So just an example of a lake in Florida. And next slide, my penultimate slide is talking more about our water quality capability. What we do, in addition to SDB, is an actual quantification of water quality parameters, in this case, turbidity. This is an application that they were concerned of turbidity encroaching on coral reef areas off the east coast of Australia. So we're giving a spatial map of turbidity to make sure that we can show where this turbidity is extending, as close as the reef as reef and areas of interest. Next slide, please. So that's basically it. I know it was a lightning session, but the beauty about a lightning session is you can always contact me for more information. I hope I gave you a very brief snapshot of what EOMAP does and our technology. And this is my email address. Thank you very much.
Great. All right. Thank you, Edward. And all the presenters, we're going to take a shorter break than we had on the agenda so we can stay on schedule, but we just had lunch. So if you guys don't mind, you want to grab anything and bring it back in, make a quick bathroom break, and let's get back on for the rest of the lightning talks at a quarter till. So that is 1:45, right? At 1:45. All right. Thanks, everyone.
All right, we're going to go ahead and get started so we stay on time. Thanks to folks for sticking around through the long haul. So we're going to finish the lightning talks now, and I think everybody is here for these. So the first lightning talk will be by Amar Nayagandhi with Dewberry, and he's going to talk about seamless topography and bathymetry mapping in Florida for NOAA and that Florida Water Management District.
You. Good afternoon, everyone. Thanks for staying till the last session. Okay, so Emily this morning's presented on the work we are doing for the FSMI project, and I'll go a little bit more into what we've been doing elsewhere in Florida for other projects as well. We've been busy in Florida over the last 5 years or so, going from doing the topography mapping, pretty much the Peninsula project that was awarded through USGS. For topographic LiDAR, QL1, to doing both big and smaller projects for various different entities with NOAA, and what Stephen White just presented was something that we've been doing for many years in Florida, but also some of the smaller projects for the water management districts, smaller in size, but definitely very impactful as well. So I will be talking a little more about those projects, and so Emily already presented this morning on the big work that we are doing for FSMI. So these are the 3 projects I'm going to talk about: Tampa Bay with Lacoochee River and the Indian River Lagoon. So let's start with Tampa Bay. This is work we've been doing with or for NOAA and the NGS Shoreline Mapping Program. The first, we've done it in 3 phases, and the first phase was the Tampa Bay North area. You can notice that with NOAA's biggest interest being the shoreline, we weren't really tasked or asked to fly and collect data for the entire bay. And when we started the project, we actually used the Regal sensor that we have, the VQ880G2. It did great for the project that was flown, and we were able to get really good data. But when we got the South region, we did have our seasonal sensor. Back then, it was a seasonal NOVA while our Supernova was getting ready. And we flew that, and we actually got a lot more data than was expected or anticipated by NOAA. We went well beyond their boundary. You can see those yellow boundaries. So after that, NOAA came back and said, "Hey, you guys are collecting such good data in the bay. Can we also collect that polygon in the middle?" And so we defined that yellow boundary, and we just collected this recently. And you can see this is most recent quick look overlaid on the existing data. We pretty much covered most of the bay now. There is a small portion that we are going to go back. You can see that sort of that shaded area there that, and you can see the channel. We are not going to be able to map the channel with LiDAR. That's typically much deeper than what we would be able to get. That's, the ship channel. But that area above, we're going to try and go back and see if we can map that and, consistently get that bathymetric coverage. I'll spend a few minutes on the Svitlikuchi River Watershed DEM. So we've been doing a lot of work with the Water Management District, specifically the Southwest Florida Water Management District. And this is, again, bits and pieces of collection of data, but also creating the DEMs that they need for the minimum flows and levels projects. And so we've almost taken data for existing data, collected new data with different sensors, different techniques, whether it's sonar, whether it's LiDAR, and put it all together to create this, this DEM of the entire watershed. And I'll go through a few examples of what we've done. So we started with the lower Svitlikuchi River watershed, and there was some existing data there, but we also had the topographic data that was collected as part of the Peninsula project. So we put all of that together, but we also realized that we needed to collect topobathy LiDAR as well as multi-beam acoustic sonar. And so took all of that together. We did a bunch of collections, and you can, I think if I go through this slide, it will show me there was this one area along, again, the river channel there that after we collected the topobathy LiDAR, we were not able to collect it with the channel with LiDAR. So we went in with a multi-beam and collected that. So that was the multi-beam collect. The rest of it was the LiDAR collect. And then we put it all together to create this topobathy DEM. And here's just a zoomed in version of one of these collects. So you can see the kind of level of detail that we are getting through various different types of imagery that were collected, including, you can see within that area where we collected multi-beam, we also had topo LiDAR, topobathy LiDAR as well to create this DEM for the whole watershed. There are a couple of spillways where we actually weren't able to get either topobathy LiDAR or get a multi-beam because of, it just wasn't able to get, the boats could not get in there. So we actually used a Z boat to do that as well. So here's a really good example of this Svitlikuchi River watershed. And it really shows the different data sets that we use, the different types of data, including ranging from LiDAR to topobathy, as well as both multi-beam, single-beam collections, and in some cases even pole soundings, because they were just so shallow and so turbid that we weren't able to get it with any other method as well. And in some cases, those were the only existing data available. So that's how we put this data set together. The third project I'll quickly talk about is the Indian River Lagoon. I think that was referenced earlier this morning as well. And then, Fugro has an area that they're collecting outside of this area that we collected for the NOAA National Geodetic Survey, a shoreline mapping program. Again, really good quality data. Stephen mentioned it in his slides as well. Some of the key things to over here is that, again, we weren't successful everywhere because there were some areas that were just way too turbid for us to be able to get fairly shallow, but quite turbid as well. We also had an issue with trying to get Cape Canaveral. I think Malcolm mentioned that in the morning. I tried to call Elon Musk on his cell phone. I wish I had his phone number, but that was the biggest problem. Again, NASA was fine with us getting in there, but they would not. SpaceX essentially said you cannot get in while we have any of our technology out in the open, and they always have something out in the open there as well. So we weren't able to get in. We did NOAA extended us a survey up north along the coast, but they actually did, I think, manage to go in a few months ago with their NOAA aircraft as well as their own sensor to actually go and map in that little area around the Cape. So that was another project that we worked on. So in summary, and I think this really helps in terms of how we've been doing a lot of these surveys in the past and in the recent past is, using LiDAR first, topography LiDAR first, and then filling in gaps with sonar. That philosophy has really helped us, whether it's a small project like we did with the Withlacoochee River watershed, or much larger projects like what's going on with the FSMI program, really allows us to be able to get what we need, and it's most efficient in terms of data coverage and collection as well. And again, we all know why we are collecting these data, and there's so many good reasons to do so. So I'm really glad to have been involved in this. And again, any questions, please reach out to myself or Emily. Thank you.
Thank you very much, Amar. Okay, next up, we have Jeff Danielson with the USGS, and he's going to talk about existing and planned CONED work in Florida.
Thank you very much. Great to be here. I'm going to talk about CONED's work. Work here. Let's see. There you go. Okay, so the USGS, for those who do not know, USGS CONED project is a project within the Coastal Marine Hazards and Resources Program, started in about 2012 to basically create, regional topography models to support science applications. The project also has a research component to look at things like satellite-derived bathymetry and other remote sensing methods to help fill in gaps in these large regional scale models. Obviously, sources of data for these models is, everything across the federal sector that's in the U.S. Elevation Inventory. So from NOAA, Army Corps of Engineers, USGS, you name it, we try and bring in all that data to create these regional models at a 1 meter spatial resolution. What's critical is that everything is, transformed and everything is consistently, transformed to be a consistent product. The stakeholders for our work is the modeling community. So I thought it was kind of cool where we talked about use cases. And I think once you have data put together into a regional framework, you're going to see the use cases go off the wall, to be honest. I mean, it's important to have every single survey, but once you have it put together, it really drives science. Yeah, if I can get this ordered. Okay. Oops. There we go. Oh. Yeah, please. Yeah, better. Next slide. Thank you. So talking about Florida, so we're building a model in Florida. CONED is partnering with Florida Department of Environmental Protection. I'm going to be building basically models with in 2 grid frameworks of UTM Zone 16, 17. Everything's going to be transformed into the vertical data of NAVDD8. But most of all the data being collected by the vendors as part of SFMI is being collected to those specifications. But as part of this work, we're going to be transforming all the pre-existing data to match up with the overall project. Next slide. To talk about the workflow, just briefly mention this. We have a published workflow that was established in 2016 by myself to integrate at a regional scale across the U.S. coast. We've completed so far 65% of the U.S. coast across the nation in terms of integration. We basically have pre-processing in both the topo and bathy phases, and then we have integration where it's a stack of rashers coming in, and then we prioritize based on accuracy and frequency. We fill gaps if necessary, smooth transitions, and then we've also added some new steps to improve the blending between moderate to high resolution data, as well as to remove sort of the effects of ghosting shorelines. If you have different types of data coming in with different representations of shoreline, you want to maintain the most current shoreline representation in these integrated models. Next slide. This shows an example of what has been done so far in Florida. So we have completed the Atlantic side of Florida in terms of the version 1 integration at 1 meter. This gets to some examples that Amar was talking about. This brings in all the peninsular topographic data from 3DEP. Also brings in a lot of pre-existing data from a number of the hurricane post surveys that have been done in the past from Irma, Marie, Nicole, and so forth, and that have all been Matthew. So we sort of looked at what was available, published on Digital Coast and NCEI, and we pulled in all that data into these models. You're seeing a couple graphics over Marathon, Florida, and Florida Keys, where it's been integrated in this version 1 framework. Next slide. This shows an example over Daytona Beach where we've actually, brought in Hurricane Nicole data from Army Corps of Engineers JoboTech. So it's very useful to have a very recent post survey, and you're seeing just a profile, going from offshore to onshore, which is what you want to see in these type of regional models. That type of look and feel as you go across the landscape. Next slide. This is a really cool slide for the Everglades. So, one of the biggest holes in what I would call DEMs for across the government was, the Everglades really didn't have very good DEM coverage, for the most part, at least put together into a seamless composite. And so, thanks to all the previous work by, vendors in this room, there was lots of good BAPI LiDAR data acquired for the Everglades, thanks to Dewberry. And so we put all this data together for the Everglades, including with the topographic data from 3DEP. And this is now a really nice composite for the Everglades as part of this version 1 pre-model. And, there's a lot of folks now wanting this data set for just ecosystem modeling because it really adds a lot of value for the Everglades. Next slide. So this is, I think, my last slide almost, but it talks about our plans for Florida, where we'll be building a pre-existing model for all of Florida by the end of 25, which will bring in all the, EON data and all these pre-surveys and put them into a version 1 model that extends from the whole Florida area, from basically Alabama to Georgia down to the Keys. Version 2 will be incorporating all the data from the Florida C4 Mapping Initiative, which is what you've been hearing so far in this room, taking those grids and putting them into the seamless composite into those different UTM zones that we are breaking it apart at. It's a fairly major effort. This is a huge project. I mean, no doubt about that. But, we've worked in large areas before, like in the Gulf of Mexico, building a seamless model from Texas all the way to Alabama. So it's not like we haven't done this before. There's a lot more coordination, and there'll be a lot more, timing is everything. and that will be kind of a challenge. But next slide. I just want to promote satellite-derived bathymetry. So we've done a lot of research with SDB. And so I love hearing, talks on SDB in this room. We actually had a project funded from the Office of Naval Research to look at satellite bathy methods over Florida Keys, Guam, and Puerto Rico, and to look at physics-based methodologies using photogrammetric approaches. So next slide shows an example over Key West where we took stereo photogrammetry and derived, basically seamless topobathy from satellite systems. And with a slight little bit of calibration, you can get down to, roughly 57 centimeters if you add in a little bit of calibration. But this method can also generate a model without calibration, which is why it's useful for the Office of Naval Research in areas outside of the U.S. And I think that's my last slide. Next slide. Thank you.
Thanks, Jeff. All right, so we are on to second to last presentation. This one will be by Jennifer Wozencraft, and she will talk about topobathy data collection by the U.S. Army Corps of Engineers JoboTech.
Figure out all the electronics up here. Okay. All right, I'm going to give you a little bit of background on JoboTech's National Coastal Mapping Program and some of the activities we have going on pretty soon in the state of Florida or upcoming. So JoboTech is the Joint Airborne LiDAR Bathymetry Technical Center of Expertise. It's our interagency collaboration in airborne LiDAR bathymetry and complementary coastal mapping technologies among the Corps of Engineers, Navy, NOAA, and the USGS. We've been collaborating and cooperating on those technologies, coordinating our mapping activities for about 25 years now, and we have a slew of other folks that we work with and government industry and academia, and we feel like we've got a really nice community of folks moving the technology forward. And we, of course, invite anyone to come join us and help us move these technologies forward. One way we do that is our annual workshop, and that's coming up in October this year in Anchorage, about as far from here as you can get in the United States, but you're welcome to attend. So send me an email if you'd like to get on our email list for that. A couple of community resources just wanted to touch on really quick. We have our JABOTEX Airborne LiDAR bathymetry specification that I've presented a couple of times at this meeting. And if you'd like to join a working group to discuss that and suggest changes, you can scan that QR code and do it. And then since there's so much topobathy LiDAR collection happening in the state of Florida right now, I thought I would point you to two resources kind of describing the technology in a little bit of detail. One of those kind of started JABOTEX that was published back in 1985. And the other, which is an update of that version called Airborne Laser Hydrography 2 that's available on Cornell's website. Dr. Bill Philpott was our editor for that. So please reach out to those if you'd like to learn more about the technology. And now National Coastal Mapping Program. So this is the Corps of Engineers program where we collect data around the coast of the U.S. on a repeat basis. And the intent is to measure coastal change to support regional sediment management. The Corps dredges sand out of navigation channels, and one of our goals is to use that sediment as a resource for our flood risk management or beach projects or our ecosystem restoration projects, or to otherwise support the overall resilience of our coastlines. And we've mentioned this program a couple of times during the meeting, but we do collect a fairly skinny strip of data along the coast, and that's kind of shown in the upper right-hand corner. So it's 500 meters on land to 1,000 meters offshore where the laser works. And that's to capture the active part of the beach profile where the sand's moving the most. So the beach and dune system out to the depth of closure. We collect aerial photography along with that. Like Amar said earlier, LiDAR wins, the imagery might look terrible. And we have started this program back in 2004 in the central northern Gulf of Mexico and worked our way around Florida through Maine, the Great Lakes, and back down the West Coast and over to Texas. And we've actually completed that circle 3 times and are working on our 4th way around. I went and did it. Okay, yeah, I got back. So focusing in on Florida, we have collected, our regularly scheduled program 4 times. So that's the NCMP round 1, 2, 3, and 4 that I've got listed there, the years of those surveys. So that's our normal round the coast surveys, but we've also done a lot of mapping in the state of Florida as a result of hurricanes. So you can see each of the different hurricanes that we responded to through the years. So in a lot of the state of Florida, we have 7 or 8 different, instances of LiDAR surveys that we've collected since 2004. So that's a big set of data that we've got available to do some analysis on, as was mentioned yesterday, I think, by one of our participants. We do create standard products from our LiDAR and imagery data sets. You're seeing 2 of them here. We do a first return digital elevation model as well as a bare earth, along with some photo mosaics, zero contour, and of course FGDC metadata to go along with everything. And I have a lot of different uses of the data on this slide. I need to graphic-ize this at some point, so it's not just a big list, but I'll let you look at that later. I think you'll have access to the slides, but the Corps uses the data in a lot of ways. Other agencies use the data in a lot of ways, and it's all available through publicly available websites like Digital Coast, our grid system, and then through web services too. And moving on, if I can, to our toolboxes. So you may have noticed on the Florida slide that our last survey was in 2022 and our next one's coming up in 2028. So you probably don't want to hear about a survey that's going to happen 4 years from now. So I'll talk about the different types of analysis we're going to do on the data that we've got in the can. So we've created a it's actually more than that, but a few toolboxes that run out of ArcGIS Pro that are Python based. That help us analyze our data. One is a quick response toolbox where we can compare 2 data sets collected in one location to do elevation, shoreline, and volume change, and we use that after storms. The multiple data set toolbox is an iteration on that where we can put in more than 2 data sets and look at trends of change through time, and the other is our profile feature extraction toolbox, and I have some examples of those. But the first thing we have to do, they all run on baselines and transects. If you know a coastal engineer, you know they love their beach profiles. So that is what most of our analysis is based on. We do a baseline that's in a long shoreline along the first line of infrastructure and then cast transects off of that. We are right now creating a nationwide set of transects, I believe, at 10-meter interval. So that will be becoming available for the state of Florida soon that we're going to use, and you are also welcome to use. We'll publish that like all of our other products. And then we also use it in our volume change toolboxes. So we don't do average end area method, if you know what I'm talking about, for volume changes. We just use the transects to bound our boxes. So I should have said in the baseline and transect section, if you have your own profiles like the R monuments in the state of Florida, you can use our toolboxes on those as well. My timer went away. Oh, I have 1 minute and way too many slides. So this is our Hurricane Ian regional volume change for the FEMA beaches. So you can see that we've got volume changes computed for several beaches as a result of Hurricane Ian. These are some of the outputs on the right-hand side of the slide from our toolboxes. You see the traditional, I guess, alternating erosion on the beach, deposition in the offshore, and then the bar moves offshore. There's some references there. We've got to publish the Ian work with some references on how we use that tool. There it goes. Our profile feature extraction, and I should have a USGS symbol on this slide too, because we've worked with those guys for a long time on doing extracting features from profiles like the location of the mean high water shoreline, the dune crest, the dune toe, and what we want to do is compute all of these different coastal engineering features that you see on the left-hand side of the slide. And we use that information with some Corps of Engineers wave hindcast data, as well as NOAA extreme water level data to compute what we call a coastal engineering index. This is not community resilience. It's strictly the things that we can build on the beach. So it's related to the height of the dune, the width of the beach, the slope of the beach, but we are able to compute, at each of our transects along shore a value that is an indicator of what the coastal engineering resilience would be. So if you look at that in one of our web services, you can see the results kind of on the right-hand side of the slide. It's a stoplight indicator. So red is relatively lower resilience than blue on the top. And then you can see each of those features extracted in the lower profile. And if you're able to look, am I out of time? You are able to, if you average coastal resilience for all of those profiles for a single beach project, you can track it through time. So this is an example at Panama City Beach, where it shows we had low resilience until the Corps of Engineers put in a beach project, and then the resilience went up, and it's actually maintained that resilience through time. And then my last slide is our dune vegetation toolbox. So it's another toolbox and runs out of ArcGIS Pro, but requires an NVIDL license to do some analysis of our hyperspectral imagery and LiDAR to say things about the density of dune vegetation, which is important also for coastal resilience. I think that's it, Cheryl. Just trying to get. And I rely on all these people to do all those things I just showed you.
Great. Thank you, Jennifer. All right. Last but not least, and then we'll get into, I hope, a hearty discussion, a little bit of a discussion session. But right now, Kyle Goodrich with TCARTA will talk on space-based bathymetric LiDAR surveying of Florida's coastal waters.
All right. Good afternoon, everyone. Thanks for sticking around for the finale here. And last but not least, but maybe the least here, I will say it's the least expensive, least deployed technology, and maybe the least familiar within this crowd, satellite drive bathymetry. And it's been great to see Jeff and Stephen and Edwards talk previously to introduce satellite drive bathymetry and speak to the benefits of it within the coastal mapping community. And I admit my talk is actually going to be about satellite drive bathymetry. I kind of thought I had to put LiDAR up here just to get into the agenda, because satellite drive bathymetry isn't really mentioned very often. But so I snuck it in here a little bit. But because I will say, we're following this opportunity as a satellite drive bathymetry provider, as a small business based in Colorado, and following this opportunity. And I admit, the first time I see a solicitation out for coastal mapping, the first thing I do is Control F and look for satellite. And it never popped up in these documents. So I was like, oh, maybe this isn't for our technology. But it's been great to see it kind of come into the conversation today. And I hope this will kind of continue that conversation and spur some thoughts. Oops. So we were able to participate in the Florida Coastal Mapping Program. We were thrilled to be invited to be part of the Dewberry team and provide some satellite-based water quality assessment ahead of their airborne LiDAR programs. And I've seen a couple of visuals of water quality metrics and ways to evaluate that to predict LiDAR collection. And it's usually with Sentinel imagery freely available in monthly averages, which, you know, gets you somewhere in terms of seasonality. But we've taken it a bit step further and used planet imagery. Planet satellites are, you know, they're small sats. They collect imagery passively around the world every single day, everywhere, every day. They're now 8 bands, so that provides more bands of information for us to calculate water quality information. So what this gets you is a daily look at the water quality of your surrounding. Now, it's not forecasting. We're not quite there yet to be able to predict when water is going to be clear, but we can look backwards in time and look at historical comparisons on a daily basis, aggregate those on a weekly basis, and get more finite information about when to deploy your assets and when to get the best data collection. There's a lot more information you can do than just besides KD 490. You can get backscatter, set key depth, and various other sediment contents, suspended materials information on the on your location. Depending on your how and where you're working, some of these metrics might be useful, some of them not. And, you know, it's a little bit of open discussion about which ones are the most informative for collecting LiDAR. But that said, having this information on a more daily basis and know whether this is better than average or worse than average is more information that you're going to get from a monthly average. So to get to the title of my talk, space-based LiDAR mapping of Florida coastal waters. I've heard a couple of mentions of ISAT-2 sensor, and that is a very exciting sensor, and it has changed satellite drive bathymetry technology over the past 5 years. This is a satellite that's operated by NASA, freely available data. The raw data you can go out and collect for free, but to get to bathymetric information requires specialized information, and we have done about 4 to 5 years of research and development to extract this data out at scale, understand how accurate it is, and to be able to how to deploy it for coastal modeling around the world. It's a useful tool for validating satellite drive bathymetry surfaces, as well as doing some just coastal information itself. I'll give some examples of that later on. But you can see here, there's 5.8 million sounding points that we derived from this sensor around Florida. Just freely available, sitting on an archive somewhere, just needs a bit of processing. And sure, this isn't complete coverage. This isn't going to be anywhere near what airborne LiDAR is going to provide you, but it provides you a modern baseline to be able to do your operational planning. Furthermore, you can take that satellite ISAT data, and as Edward actually mentioned earlier about using the ISAT sensor to validate a physics-based satellite drive bathymetry method is a very powerful tool, because one of the limitations of satellite drive bathymetry historically is how do you validate your depths if you're working in an area without any in situ information. The ISAT-2 sensor provides that secondary validation so you can provide accuracy assessments of your satellite drive bathymetry surfaces. What you can see here is a 10-meter satellite drive bathymetry surface of Florida. Done. I don't know what the problem is, guys. This is easy. 2 weeks. We did this with interns, right? I mean, we don't care about El Nino or weather, this or that. What we did, we took the last 18 months of satellite imagery, freely available satellite imagery, used our water quality metrics, found the best images, calculated the bathymetry, and then aggregated all those depths. So we ended up with 20 images on average per tile, up to 50 in some places. So you get 50 measurements for every 10-meter pixel on the seafloor. Now we're getting to some fairly accurate information, repeated measurements. And to answer your question, 27 meters depth, maximum depth. And the majority of it is in CATSOC A2. So it's quite accurate and validated with a secondary satellite sensor. This provides a modern day baseline for where's my 10-meter contour, where's my 20-meter contour, where should I expect to get data from my LiDAR system. And here's some derivative information from both the ISAT sensor set data in the upper right, showing just colored bands of depth from 0 to 5, 5 to 10. You can see between the yellow and the green, that's your 10-meter contour line. Between the blue and the dark, the purple, that's 20. And then in the other images are the 10 and 20-meter contour line from the satellite drive bathymetry around the Florida Keys and where is that? On the east side up by Canaveral, which I've been seeing some challenging data being collected here around Cape Canaveral, and satellites can do it because you just find a satellite image with clear waters, and Elon doesn't care, doesn't know if we're taking satellite images of his launch pads. We can just take images. So it's useful information on all these access denied areas, as well as these areas that have heavy turbidity and that you don't want to deploy an aircraft 5-10 times just hoping for clear water. Satellite drive bathymetry can infill those gaps quite easily by just finding a clear water satellite image. But I mean, Florida's already kind of in the process of being mapped, right? You're already going to be collecting LiDAR. And once you collect Topo Bathy LiDAR, why do you need a lower accuracy, lower resolution satellite drive bathymetry product? I will say, you know, we produce that data from 10-meter resolution satellite imagery, and everyone says, oh, 10 meters, what are you going to do with that? Well, it's freely available satellite imagery. If we can spend money and collect commercial satellite imagery, we can get down to 3-meter resolution. We can get down to 1 meter. We can get down to 30-centimeter resolution if we're willing to use commercial satellite imagery. But usually people say, oh, that's too much money. So there's a trade-off whether you want free at 10-meter resolution or you need to pay for commercial satellite imagery to get better imagery over clear waters. But that's a potential strategy going forward for this program, because I don't know if you're going to get $100 million next year or 5 years or ever again for coastal mapping. And satellite drive bathymetry can be used to both infill gaps in your current program that you're doing, rather than fly LiDAR again for these little bits and pieces of pixels trying to fill that in. Use a satellite image. Secondarily, you can use satellite imagery and satellite drive bathymetry to identify where change has occurred. Rather than go out and fly an aircraft or deploy a boat to see if there's a change, use satellites. Determine you've established a baseline with LiDAR and sonar with this program. Continue a change detection program with satellite imagery, and voila, you've got a way to monitor where change is occurring and deploy future assets to map the coastline effectively and efficiently. And it also could inform the survey decay rate that Noah showed earlier about age and change and the morphology of the seafloor. This can actually give you positive identification of when that seafloor has actually changed. That's all I have. My eye candy obviously shows big, broad areas, showed all of Florida coastline being mapped, because satellite drive bathymetry is a highly effective and scalable technology that can map areas effectively and efficiently, and it complements these existing technologies that you're deploying here. Thanks for your time, and I look forward to questions and discussion. Thanks.
Thanks for getting us back on schedule, Kyle. So, yeah, so right now what we'd like to do is, I know that we had audience questions coming in online, at least before the break, or maybe comments. We want to start, if there's any questions on any of the lightning talks, whether it was before the break or the 4 that you just saw. So was there anything online? Okay, all right, so no question, all right, for any of the speakers here. All right, anybody have any questions in particular? I'll start with one then. People who are advocating for satellite-derived bathymetry, it's very intriguing. When you can achieve a commercial satellite 1 meter DEM, what is the vertical accuracy? Microphone. I'm like, does he want it?
So the vertical accuracy, we target 10% of water depth. So 1 meter and 10 meters of water, 2 meters and 20 meters of water. That's generally what we target. If our information from the algorithm is coming back that it's not that accurate, it gets removed as no data. And that's where multiple images and stacking those images and calculating multiple times and averaging those, accuracy has really improved over the years, whereas before it was a little bit of a crapshoot of how accurate that data was. And I'm sure Edward can elaborate as well.
I can only agree more than anything. I think this what we're required to report is plus or minus 10% of the water depth. In reality, we find that we're much more accurate than that. We find that you know, it really depends on the conditions. You know, there are some tricky conditions of varying bottom colorations that will create some kind of difficult returns. So in those areas, we either get inconsistent data or, larger error bands. I will say this, that we do provide vertical uncertainties for all of our mapping so that you have a better understanding of what that error band would be. That's standard in all of our deliverables.
Great, thank you. All right, other questions? Yes? Not?
I have a follow-up question on that. So has there been any work done to look at the comparability between LiDAR? Say we were to use a mixed system of both satellite derived and LiDAR to monitor change over time. This might be an opportunity to calibrate between those. Is there any work done on that? Is there a feel for it?
Yeah, I mean, we've done extensive comparisons of satellite derived bathymetry with LiDAR, either whether that's to infill gaps in the LiDAR data, or to just what was I going to say? Combine it with the data to combine more complete coverage. So there's ways to use it in combination, and we have done validation of the satellite derived bathymetry results with LiDAR around the world wherever we can. Those true one-to-one comparisons are, I admit, hard to come by, of getting that LiDAR data that's collected on the same day as the satellite image, and that it's like chasing your tail a little bit, but we've done some pretty good one-to-one comparisons on it around the world. Yeah.
Yeah, I second that. We have our own comparisons. We have some publications which I can send to you if you're interested. So please get in touch with me and I can send you that.
Because all this discussion and this confidence in the satellite derived bathymetry, that the whole issue of the temporal scale of data collection, we have this foundational baseline as a result of the FSMI, but maybe then periodically making the lesser investment of getting some commercial, maybe not the 1 meter, maybe the 3 meter would be good enough to do periodic updates, and at least the shallow water zone might be a good approach to start thinking about.
Yeah, and may cost only like 1 or 2% of
Correct.
the budget that you're talking about. Yeah.
I can only agree with you, Cheryl. I think that this is fascinating technology that's only going to improve. It has been improving leaps and bounds over the last, 30 years, but in particular the last 5 years. So yeah, I think that it's time to really take a close look and see where we can maximize the value here.
Yeah, absolutely. And I think you guys have said that you've done extensive comparisons and you have publications, but I think that something that might be really useful is to do that exact same thing for Florida once there's some Florida, once some Florida data is publicly available, because we could use that to sell the validity of keeping the FSMI going or having an FSMI 2.0 that was using satellites.
I would only add that one thing that's been a bit of a hindrance to that is actually the pace of releasing our processing the multi-beam data or LiDAR data. That geodynamics project I showed earlier, we actually tried to coordinate with that survey to do satellite derived bathymetry on the same day and all that, and we're still waiting on getting the data. And that's one of the hindrances. Everyone wants that one-to-one comparison, but it takes years to get that data to do that comparison.
Good point.
Can I ask, and maybe Jeff would know, or somebody on the federal level, I believe, my understanding is that when partnering with federal agencies, we can access some of these commercial products. Maybe not Worldview 2 or 3, but GeoEye or some others that are higher resolution. Is that an option?
Don't quite understand the question. I mean, we do use, Worldview 2 and 3. Oh, you mean that?
I mean, as far as costs.
Can be
Yes,
provided to us
cost.
free as costs, as you mean?
You know anything about that?
Yeah, I mean, so as federal agencies, we can access the Maxar satellite data for free, actually, through the NextView contract, which is a contract through NRO. That's actually managed by NGA. So, and actually where I work at the Earth Resources Observation and Science Center, there's a commercial remote sensing program. So that's called CRISP that actually allows federal agencies to get access to high-res commercial data. In fact, they can task, they can put in data acquisition requests to request an area from Maxar over anywhere in the world. It's actually that the request gets put into NGA and then they put that into the system. There are some restrictions regarding what you can do though. It's got to be, you have to, you can't share the imagery, for example, and you can use it for derived products. So there is some limitations there, but you can use it for doing like STB, for example. And also if there's a state agency partnering with the federal government, they can also use that data as well.
Thanks, Jeff.
If I could double down on that, Jeff, yeah, we've used that mechanism for the federal government to provide commercial imagery to TCARTA to produce data for the federal government back to them. So it's a very cost-effective way for the federal and state governments to use commercial imagery and not have to buy it twice. And that's I suggest people look into that for future.
Buy once, use many times.
This question's for Jennifer. When you were talking about your making the profiles and you used a first line of infrastructure, is that a loosely defined boundary, or is it like based upon a sewer line, or is it sidewalk, street, et cetera? I'm thinking in terms of comparison situations.
It's a loosely defined feature. We manually kind of digitize it, try to pick, if you saw the example, it was kind of the centers of the first lines of buildings along the roadway or along the beach.
Other questions or thoughts on presentations that you saw?
We do have a question. 1 second online.
Wiley was asking about the feature detection and capability of satellite drive.
Oh, yeah. So I was asking because anytime I see CATSOC, my navigation brain clicks in. And so CATSOC has feature detection requirements as well as horizontal, vertical uncertainty and coverage. And one of the things we struggle with both TopoBathy and STB as well is, the waveform actually getting the top of the feature and having like a least depth capability, like finding the top of that feature and finding 1 meter feature. So, obviously if you're looking at 10 meter resolution, you're not going to find 1 meter features. So the CATSOC for all of our TopoBathy and STB is B at the highest because feature detection capability is false. And so I'm always interested because, there's new technologies with TopoBathy LiDAR. If there's been any new studies on feature detection capability and previously we've been told just how the waveform works in physics, and it can't quite capture the top of features reliably within the vertical uncertainty. So if there's any new studies on that or any, conversations that we can have to get to the point where we can have higher CATSOC for TopoBathy LiDAR and other satellite derived bathymetries, I think I personally would be really interested in that. So that's what that comment was CATSOC includes feature detection.
Sorry for hogging the Q&A here, but yeah, that was reference to my slide on the CATSOC, and I that should have had an asterisk on it, and I knew it was going to be a lightning rod top thing to put up there, and that would be, we have done feature detection from high resolution satellite drive bathymetry, and there are limits, obviously, the size feature that you can identify. So some of that is forward leaning into the IHO and the CATSOC levels could be adapted to include satellite drive bathymetry feature detection if the aperture was widened a little bit. So that's a little bit of a forward leaning to get it to A1, but feature detection from satellite drive bathymetry is a thing. And we have, there's publications and we've done that for the federal government. It does have some caveats and different things that come along with it, but that, as does any other technology when you're adapting to a standard that's not meant for that technology.
We seem to be swirling around the satellite bathymetry, but I guess it's a good thing if it's a new technology and we might be thinking of adopting it. And my question is, you had mentioned, Kyle, that one of the things you do is you get basically like a time series of the same location, right? Where you could, but what if that location is changing through time? So yeah, like that occurred to me when you were describing.
I think
that.
Edward mentioned that as well, but you can, if it's changing over time, you're using just the information of satellite and seeing that change over time. You can see that sand dune move and see a relative difference between those two. Depending on which method you're using of satellite drive bathymetry, whether you're using a calibration method or a physics-based method, you don't need that information from in situ, and you can just calculate what that image provides you and then see the difference, the next image and the next image and the next image.
Yep. Okay, good, thanks. Any more audience questions, thoughts?
No, just to add to that, obviously
Thanks.
in places where we have constant or expect constant bathymetry, the multi-image method will provide a hugely improved level of accuracy. So rocky or reef type of environments. But where you have bed forms that are expected to move or dynamic bed forms, as in 90% of Florida, you will have to rely on single image bathymetry, and you can obviously, if you have confidence in your process, you can track that over time, of which I showed in my presentation. So
thank you. Other things? Yeah. Wait for.
Brian, if you're, we see there was a comment or question, you're welcome to unmute.
Oh, thanks. Yeah, I was just wondering, with a product like the T-Carta that Kyle was mentioning, what's a pathway for that to become publicly available?
That's a good question. We do have a fair bit of our data that is publicly available through the Digital Coast up in Alaska that was contracted by NOAA and then made available. That data that was produced in Florida was done on our dime. So I'd be happy to consider it. We have looked into contributing the data to the National Bathymetric Source previously, but it's been one of those kind of satellite drive bathymetry bastard childs of bathymetry that they don't actually want it. So it's been hard to understand whether what is that pathway from the federal government side? I'd ask back.
It seems like there would have to be some sort of effort to develop standards and specifications, right? Yeah, there are. Okay. All right. Yeah. Oh, so IHO does have those for satellite drive bathymetry. Thank you. I didn't know that. I'm learning a lot.
So from the EOMAP side, we do obviously provide any data that is contracted to any federal government is eventually made public. We also have recently won a grant from the European Space Agency to provide 100-meter grid data worldwide, which will also be public. And we've also developed a web application that anyone can use. This is a commercial application though, but you essentially go in and you buy credits and you can actually develop your own satellite drive bathymetry, but it's not free. So, but yeah, contact me if you need more information on that.
It's not free, but it is accessible. So that's good.
That's what I meant to mean. Thanks, Cheryl.
Yeah, no, that's fine. Anything else online? All right, so let me then ask sort of logistics questions about FCMAP in general. You guys keep showing up every year, so I'm assuming this is valuable information and a worthwhile gathering. It certainly is for me. And last year, we made the decision that we wanted to have the annual summit be sometime in the late winter, early spring kind of time frame, just because we were having it before and sandwiched in between Thanksgiving and Christmas, and it was just too hectic for everybody from all sides of things. And so last year we had a mid-year forum just to kind of check in August, because we were going to be waiting until March for our next meeting. Is it worth your time to spend an afternoon 6 months from now to get a stakeholder update? Like, you know, it would just be all virtual, an afternoon, 3 hours, whatever, and just to get an update. I just kind of want to get a feeling for whether that's worthwhile to you. So show of hands, maybe, if you think that, yeah, we should do that. Okay. Yeah, some people find it valuable. So we've also lost a bunch of people. So I'll double that amount and call it a yes. Well, I just think there's going to be a lot of mapping probably completed again because of the FSMI. There's going to be a lot more that can hopefully be shared. I would also encourage, some did it and some didn't. In a lot of the eye candy that was shown from the imagery, from the LiDAR that's been collected, as well as in some of the lightning talks, I noticed that on a lot of the kind of 3D renderings of bathymetry that people were showing, and with the different color ramp showing depth, most of the presentations on those images did not include any sort of scale bar with the color ramp. And maybe it's just myself, but I kept finding like, well, that's dark blue. What is the depth there? You know, so I'd encourage you, if you are going to show those kind of eye candy, if you can put a scale bar on there, that would make the geeks in the room whose eyes just immediately want to know that information very helpful. Selfish question or selfish comment. Anything else, Renee?
No, keeping in mind, you know, we still have the presenters, I think, from earlier in the afternoon. So if there's no other questions in the room or online, I think we're in a good place. Any general topics while we on the agenda, we still have a few minutes. So if there are any general topics anybody would like to cover or bring up.
I think people probably burn out.
Yeah, I think we're reaching the end here.
So we had, the earlier talks were, let's see, Blue Topo by NOAA, Christina Fandel from OCS, Sarah on the crowdsourced bathymetry, just to kind of remind you what the talks were. And then Stephen White, and then Edward on talking about the satellite-based bathymetry. So I'm just reminding people what the talks were before our presentations to try to maybe stimulate a question you might have had. All right, well then, we're not going to keep the silent crowd here, and we didn't serve you coffee at the break, so I think that's the problem. So I want to take a second and just say thank you to this rock star, Christy Erickson. She really handled all the logistics, everything. I know it's not an easy thing to pull off, and you did a great job. So thank you very much, Christy, and thanks to Kat for keeping us going online. And AV got us going, so we're good there. And yeah, just to everyone who showed up and participated, we really appreciate you. And we'll just keep plugging along. Anything else you want to say, Renee?
Yeah, thanks for the sponsors.
Yep, absolutely.